Imagine that the night sky suddenly lit up with a bright flash and a burning ball appeared in the heavens, illuminating the surface of the Earth like the sun does during the day. But the sun isn't in the sky now, so it can't be that. You're sure of it? You don't hear the roar of impacts, nor any crackling of the atmosphere, only the howling of dogs that understand before any human does. Something terrible has happened. Maybe a meteorite or a missile strike. Perhaps the change of the magnetic poles have moved the northern lights to our latitude. Your brain is feverishly sorting through options, but one thing is clear: this is a cataclysm of a planetary scale. What to do? One person decides to go outside away from high-rise buildings, fearing destruction. Someone across the street goes down into a basement where they feel safer. Many people are trying to remember where the nearest bomb shelter is. In confusion, you join those who've gone out on the roof, watching the flaming ball in the sky, trying to come up with their own versions of what's happened. And then someone asks, where exactly is it? The moon. Everyone then realizes that the fireball pulsating in the sky, flooding the night city with light and instilling it in the horror of the unknown, is all that remains of our moon. This is Ridddle, the largest impact crater on Earth. Its diameter is from 250 to 300 kilometers. Such giant holes are formed due to the fall of meteorites and asteroids with a diameter of more than 10 kilometers, which regularly fall to Earth. There's a possibility that any planet could be destroyed by the huge energy of these giant cosmic bodies. But what if this attacking aggressor is significantly smaller? For example, hundreds of thousands of times smaller. Let's see if it's possible to destroy a small solid planet or its satellite by hitting it with a tiny body the size and mass of a golf ball. When we look at the surface of the moon, we see that it's all scarred with small and, more rarely, large craters. These are the consequences of meteor attacks, because the moon doesn't and has never had its own protective atmosphere. Therefore, space bodies that attack the surface of the moon at high speed don't heat up nor collapse from friction, but reach the surface perfectly preserved. The maximum recorded speed of such meteorites is about 70 kilometers per second. That's 70 times faster than the record-breaking jet airplane. Of course, for various reasons, we can't physically accelerate a golf ball that much. This speed exceeds the escape velocity, which allows you to leave the solar system forever and enter free space. But we can assume that such a lost ball could come towards us from far away, such as a comet from the Oort cloud. If a golf ball hit the surface of the moon at that speed, nothing terrible would happen. It would break through the lunar soil to a depth of just over a meter and then explode, scattering several tons of rocks around. In the absence of an atmosphere, not even a cloud of dust would remain. The impact energy in this case would be only about 112 megajoules, which can be compared to an explosion of 25 kilograms of TNT. This incident would only leave another crater on the surface of the moon, which wouldn't differ in any way from the neighboring ones, and our satellite wouldn't even feel this mosquito bite. So, at real speeds, a golf ball with a mass of 46 grams can't threaten the moon in any way. But what if we increased this speed? For example, by 300 times. We don't know where or by whom such a ball could have been launched, whether it was spat out by a black hole along with Hawking radiation, or whether it has been flying like this for 12 billion years since the Big Bang, devouring space and time on its way. But we'll find out what it can do at home. 21,000 kilometers per second. 7% of the speed of light. Such a ball would strike the surface of the moon with a monstrous force equal to the explosion in Nagasaki, make a crater 1 kilometer in diameter and up to 100 meters deep. And yes, in fact, that's all. The moon is no stranger to such antics of guests from deep space. On its reverse side, always hidden from Earth's observers, there's even an ancient impact crater up to 2,500 kilometers in diameter. It's the largest impact crater in the entire solar system. So, a golf ball couldn't destroy the moon despite all our assumptions. But I won't give up so easily. I suggest turning the speed up to the maximum, to the speed of light. In fact, there's a catch, of course. After all, only zero-mass particles can reach the speed of light, and our ball is clearly not one of them. And the closer its speed approaches the speed of light, the higher its mass becomes according to the laws of relativistic mechanics, and the higher its energy, up to infinity. At 99.99% of the speed of light, the ball's kinetic energy would exceed 60 megatons, more powerful than the Soviet Tsar Bomba, which in 1961 triggered the largest nuclear explosion in history. Earth scientists would be able to observe a strong lunar earthquake and the appearance of a new huge crater. But of course, the moon would not destroyed nor torn apart by such an explosion. Even this speed isn't enough to destroy the moon. Let's add more nines. Then the kinetic energy of the golf ball would exceed the energy of an explosion of 7 billion tons of TNT equivalent, which is comparable to the sum of all the nuclear arsenals in the world. A fire wave would cover the moon. The lunar crust would split, and the red-hot iron from the moon's core would be thrown to its surface. The next day, a stream of meteors could reach the Earth and burn up in our atmosphere, but the moon would still not be eliminated nor destroyed by such an explosion. If we still want to continue to strive for the speed of light and accelerate our ball again and again, well, then we'll have to all agree to break the laws of physics. And today, no one knows how to accelerate it to the speed of light, but we can assume here that it's clearly not without antimatter. Forget about the 46-gram golf ball, because now, despite its tiny size, it's a terrifying monster with infinite mass and, as a result, infinite energy. It flies through the universe, not noticing obstacles. The ball pierces clusters of galaxies and black holes. It destroys everything in its path, and its route can be traced by diverging waves of energy radiation and clouds of burning plasma. You don't have to be a scientist to imagine it destroying our old moon. Of course, no one would see our golf ball through a telescope and wouldn't be able to detect its approach with astronomical instruments. Everything would happen so quickly that our satellite wouldn't even have time to react to the gigantic, incomparable gravitational pull of this object. A ball of energy which, until recently, was a golf ball, would instantly melt the lunar crust at the point of impact to a depth of more than 1,500 kilometers. In 1 second, the impact depth would reach the core of the moon, and it would be torn apart. The liquid core and molten rocks would be thrown out by the explosion and scattered around the point where our moon was once located. But that's not all. The energy of the impact would be so great that it would turn the remnants of matter into gas and make it burn. As a result, in a matter of seconds, the moon would turn into a cloud of high-temperature incandescent plasma, which would flood the Earth and the entire solar system with light and radioactive radiation. Standing on the roof and watching the growing fireball in the once dark sky, we could enjoy the howling of pets and the horror of neighbors who would feverishly be trying to remember the rules of survival in the post-apocalypse from the latest Hollywood blockbuster. However, the mass of plasma wouldn't be large enough to have a lasting effect on the inhabitants of the Earth for decades, nor even a year. In just a few days or weeks, the burning plasma would cool down due to its radiation. At first, it would simply go into a gaseous state, then condense into a liquid molten state, and finally solidify. So the Earth would get an asteroid belt similar to Saturn's belt, which would remain with us forever as a reminder to future generations of our moon. Sometimes we would get reminders of what happened because the orbits of these asteroids wouldn't be stable, and from time to time they would try to attack the surface of the Earth. But the atmosphere of our planet would be able to protect its inhabitants as it has been for the past billions of years. We would no longer see tides, nor would humans be able to build tidal power plants or use the moon's gravity, which moves masses of water to generate electricity. The night sky would become much darker, almost black, but it would be strewn with a huge number of stars that we previously couldn't observe with the naked eye. Generation after generation, tens of thousands of years in a row, people have dreamed something of their own looking at the moon. In its weak light, a tired traveler found a path. Young lovers confessed their feelings. And ancient ghouls— oh, sorry, this is from another video. Anyway, life would unlikely disappear after the destruction of the moon. Another question is how our civilization would change. Write in the comments what you think about this. And thanks for watching.